For our micro-optical assemblies, adhesives are a crucial element. And some of the adhesives are delivered in dry ice. If you want to find out why, stick around and we'll check it out.
As explained by James, we get some adhesives packaged with dry ice. So why is this the case? Yeah, those are pre-mixed two-component adhesives, and so the pot life is running, and to slow down the curing of the adhesive, we can cool it down to significantly lower temperatures.
And that is then where the dry ice comes into play, because unlike ice that we have from frozen water, dry ice is much colder. And we're talking about minus 78.5 degrees Celsius.
Exactly. Yep.
So that really is really cold. So to show you how cold that actually is, we have combined some dry ice here with isopropanol. And with that, we more or less get a sort of fake liquid nitrogen, and we can freeze stuff.
Yeah, exactly. For example, if I take this flour and put it inside this liquid nitrogen, or this fake liquid nitrogen, the flour will freeze immediately within seconds. And so if I take it out, it's quite easy to break those leaves off.
Yes. And another very nice effect that we have, or strange effect actually, when we're talking about dry ice and temperature, is the so-called singing. And how does that work? Well, we take a metal object that is at room temperature and we press it up against the surface of the dry ice, and then we get the so-called singing.
Yeah, it's more kind of a screaming, isn't it?
Oh yes, but it is also a Halloween special, so
yeah,
we'll accept it as screaming then maybe. So how does this screaming come about? Well, the spoon is room temperature and it will immediately transfer the heat into the dry ice, meaning that the sublimation process, so in other words the transition from the dry ice to the gas form, kicks in immediately, and that then actually causes a little cushion between the dry ice and the metal object, and that's then where the singing comes from, because the spoon is then bouncing on the dry ice.
Yeah, we're talking the whole time about dry ice. So the question is, what is dry ice? Basically, it's carbon dioxide. And it's the solid state, and here in this glass container we have the dry ice at the bottom, and as we have room temperature, this means it is heated up and it is transferred to the gas state. This means the jar is filling up constantly from the bottom to the top, because CO2 is heavier than normal air. And how can we prove this? If we take this lid match and if we try to insert it into the glass container, it is immediately extinguished.
And another really nice effect, and probably the most commonly known effect of dry ice, is that we see in horror movies, for example, at the cemeteries or in rock concerts or so, and that is the mist that is over the ground. And that is also made by dry ice. And how is it made? Well, it is made by adding dry ice into the water, and as you can see, we then have these bubbles, but as soon as these bubbles burst, we will have that mist. So what is that mist? Well, the dry ice is rapidly cooling down the atmosphere and the water around it, meaning that the humidity in the air coming from the water and from the atmosphere will immediately condensate, and that condensation is then this mist.
Very nice looking indeed.
Yes.
Here, if we take this jar, it's filled with water at room temperature, and if I insert now some dry ice, I have basically the same effect. If I now take this string with soap and put a membrane of soap on top of this jar, we can see that it is filled with the gas state of CO2. And what is obvious with this experiment is that the volume of the gas is a multiple of the state of the volume in the solid state.
I think it's going to burst in a minute.
Yeah.
Okay, so I hope you enjoyed this Halloween special of our Brain Snack series, and I'll pop that thing. So I also hope that you learned something, and yeah, and here's another nice little experiment that we have here, and that is going to the extreme.
Yeah.
So, I hope to see you in one of the next videos.
Yeah. Bye bye.